Hello and welcome to the webinar Carbon Sulfur and Oxygen, Nitrogen and Hydrogen Determination in Powders. First, I would like to give you some technical information. After this webinar, everybody of you will get a download link for the videos so that it's possible, for example, to watch all the content again. I would also prepare a copy of the slide so that it's possible for you to get a download of the slides we presented here today. Please feel free to ask questions via the webinar menu, and maybe it takes some time to answer them. But it's also possible to send us some questions after this webinar, so please use the email address webinar@eltra.com. My name is André Klostermeier. I'm a chemist and I'm product manager at ELTRA since 2013, and I'm doing a lot of job in analyzing samples, and I'm preparing marketing materials, and I also enjoy making webinars with you and for you so that it's possible to share analytical content. In this webinar, we will talk about different topics. First, I will just roughly introduce ELTRA for all these people who don't know us at all. Then we will talk about powdered samples in general. And then we will go to, I would say, the challenges of correct carbon sulfur analysis, followed by the challenges of correct oxygen, nitrogen, and hydrogen analysis. At the end, I would just like to give you a short summary. In the following, I will switch off the video and put on my headset because then it's a little bit easier for you to understand me, and then we can interact a little bit better. So please enjoy the coming slides. First, I would like to give you a short introduction of ELTRA. ELTRA is a German company and is located in Hahn, which is near Düsseldorf. We are focused on the producing, developing, and selling of combustion analyzers, which are mainly also called elemental analyzers. In our portfolio, we have analyzers for carbon sulfur analysis and also ONH analysis. In addition, we can also offer you surface carbon analyzers and TOC, TIC analyzers, and of course also gravimetric analyzers. ELTRA is not alone. We have strong partners. We are part of the Werder Scientific Division. This is a picture of our headquarters in Hahn, where, for example, finance department is located, marketing department is located, and we have beside ELTRA, we have also, for example, Reg here located, and some parts of MRB or QATM. The Werder Group can offer you a lot of solutions for different challenges. For example, we are present in the area of heat treatment. Of course, we are present in the field of elemental analysis, but we also have solutions for metallography, hardness testing, and of course, milling, sieving, particle characterization, and something which is more or less new is also pharmaceutical test methods, because our company Aveka near Frankfurt offers pharmaceutical testings. ELTRA has its headquarters in Hahn, but you can get in contact with ELTRA sales, service, and application specialists all over the whole world. So when you need a contact in your company, it's very easy to go to the website, and then you can identify the contact which is responsible for you locally. The general history of ELTRA started in 1981, where we first developed our first carbon sulfur analyzer. And then over the years, we are getting more familiar with this kind of analysis. Started with oxygen, nitrogen, and hydrogen analysis, and also have been active in the field of thermogravimetric analysis. ELTRA is with Werder since 2013, and during this period, we also increased our portfolio and created new analyzers to satisfy the customer's needs. In the following, I would just like to give you a general introduction about powder analysis and the challenges which are combined with analyzing powders. Maybe it's a little bit strange to make a webinar about a sample shape, which does mean we are talking about powdered samples in general. But this could have some general challenges, because when you have a look at the standards, for example, really prominent standards like the ASTM-E 1019, for example, do not consider important details which are relevant for the correct analysis of metal powder samples. In addition, for example, when you are, for example, active in the field of additive manufacturing, you are focused that maybe your sample is very different in comparison to other samples, which does mean you have maybe copper-based samples, titanium-based samples, iron-based samples. For you for the lab, it's a powder, but depending on the chemical composition, it's very critical to get a good and reliable and correct results. One thing which is also important for powdered sample is the step of sample preparation, because when you have a wrong preparation of the sample, it could mean that you falsify the results of ONH and CS in the following. One important thing which is quite often listed in standards is the preparation or the cleaning of prepared samples, which does mean a solid sample like a pin, for example, is always something which can be cleaned, for example, with acetone or with acids. But when you have to analyze powdered samples, all these cleaning processes cannot be used. And this is also the other thing which is important to know when you are dealing with the analysis of powders. The high surface of this powder could cause, I would say, irritating results due to oxidation process or maybe other absorption process. And one thing which is here listed last is more or less one of the most important thing. When you have powdered samples, you have to take care much more about safety, because hazardous ingredients could, I would say, cause much more trouble when they are present in a fine divided powder. In general, we will talk in this webinar about inorganic powders, which does mean metal powders which are part of additive manufacturing. We will talk about maybe shortly about precious metals and ceramics, and also we are, I would say, giving some hints about salts and other samples like slags and ores. Of course, other samples could also be present as powder, which just mean coke and coal paste powders or organic powders like milk powders or grass powders. But these kind of powders are nothing we will talk about here in this webinar. First, I would like to mention the relevant standards which are published for carbon sulfur and oxygen, nitrogen and hydrogen analysis. When you have a look at, I would say, these standards which take care about the analysis of metal-based samples, for example, ASTM E1019, and all the other things which are here listed in the table, uh, please be aware that these standards sometimes do not even mention that a sample shape of powder is in general allowed to be analyzed. And this is a general conflict when, for example, you are not familiar with this kind of analysis. So, for example, you are searching for a standard which, for example, cares about the analysis of iron-based powder. Then you have a look at the standard. But there, for example, you do not find sometimes additional information about powder-based samples. And this is something why I made this webinar, because when you are not familiar with a special kind of analysis, maybe a standard is the first, I would say, source of information. But then, for example, you do not get information especially about powders. It's something completely different when you are leaving the world, I would say, of metal-based samples and you are going to ceramic-based samples. For these kind of ceramic inorganic samples, you quite often get, I would say, information about powder-based analysis, because it's allowed to prepare the sample as a powder. It's allowed to make the analysis based on a powder. But again, you would not find some general hints which are maybe important for a correct analysis. And these are, for example, I would say possible conflicts you are facing with your analysis when you are not, I would say, familiar with powder analysis in first round. When you, for example, have a look at the very prominent standard ASTM E1019, which mainly cares of CS and ON analysis in cobalt and iron-based samples, you would find just a statement in one chapter that it's okay to clean the sample with acetone. But this is something you should not do when you have, I would say, a powder-based sample, because then you have maybe some chemical reaction effects or you have some absorption effects which should be avoided. The other thing is the applicable sample mass. You find in one chapter a statement that you should apply a sample weight between 0.5 and 1 gram. But this sample amount could be too much when you, for example, have a very fine divided powder, which, as I would say, is blown inside the furnace. You will find other, I would say, conflicts and I would say sources of error when you are leaving the world of iron analysis and you are going to titanium, for example. Then you will also find the general statement that it's okay to remove oxygen on the one hand mechanically or maybe chemically with a prickle and fluorine-based acid. But this is nothing you should do with a powdered sample because you would get some strange chemical effects. It's the same of preparing a sample. They only say that you have to use a nickel basket, but in case of powder analysis, you always have to apply a nickel capsule. This is not, I would say, something you are faced with when you are familiar with this kind of analysis, but please be aware when you, for example, get a powder has a different chemical composition for you, you maybe are a little bit unsure how to proceed this kind of sample. In the following, I would give you basic information about sample preparation and sample taking. Please be aware when you are the one who is analyzing a powdered sample in the lab that you are not maybe the only one who is responsible, I would say, for strange results or maybe irritating results. It's always important to know that there's a whole analytical process which is responsible for a correctness and I would say the reliability of results. Usually, the errors which have been made in the beginning of the analytical processes are higher than at the end of the analytical processes. Which does mean, for example, when somebody brings you a powder and say it's an iron-based powder, but it's not an iron-based powder, it's a titanium-based powder, then you maybe apply the incorrect settings for analysis, and then you would get strange results. It's also the effect, for example, when you have a preparation of the sample with too much heat, then already the result is falsified significantly. And especially in case of oxygen analysis, you will get in big trouble when you store the sample too long because you could have a lot of oxidation effects. The processes of sample taking are usually based on the chemical composition of the sample. So here I put some standards which deal with sample taking and put it here on the slide. For example, prominent standards are DIN and ISO 3954, which, for example, take care of sample taking for metal-based samples for metallurgical purposes. The ASTM B215 is especially created for sample taking of metal powders, and other standards are, for example, taking care of aggregates and describe the methods of sampling. They both, for example, recommend how to take your sample. And in the picture, you will find here a typical sampler for a powdered sample, which is, I would say, taken as a copy from the ASTM B215. Sometimes the samples has to be prepared as powder because otherwise they cannot be analyzed. When you here have a look at the picture of the solid ferrovanadium, these kind of big pieces are not suitable for carbon sulfur or oxygen, nitrogen and hydrogen analysis because they are just too big. Then you usually can use analytical ball mills, for example, to prepare a sample or other analytical techniques to get a suitable sample size which can be applied to the furnace of the analyzer. But please consider that the preparation processes could, I would say, falsify the results because there are two tendencies. On the one hand, you can remove an element or you can introduce an element. Removing of an element is typically something which is done for hydrogen analysis because the element hydrogen is very sensitive versus heat because it will lose the sample very fast. The other thing is also carbon, for example. When you introduce too much heat, you can maybe cause an oxidation process, and carbon of the sample will be removed from the sample. But it's also possible to falsify the result by introducing an element. For example, when you prepare the sample with a ball mill, it's also possible that you introduce, for example, the material which comes from the balls inside. It's also possible to cause a big oxidation effect because the heat inside the ball mill is too high, so that you have oxidations of the sample. When you even put more energy in it and the sample, for example, can start to burn, it's also possible that you introduce carbon because of the burning process. One other, I would say, basic mistake is you can introduce, of course, substances from the ball mill which have been, I would say, released from other samples which have been prepared before. So when you, for example, getting irritating results for your powder, please be aware that this could be a source of error. And now we are talking about the carbon-sulfur analysis of powdered samples in detail. I just would like to make aware which steps of the analysis could be critical for powders. And when you have a look at the general processes of combustion analyzers, they are always working like this, independent from the manufacturer. You are starting with a sample, you put on energy, and the sample will start to melt or will start to burn. By the carrier gas, you maybe have an oxidation effect or you have just a transporting of the sample. And our typical reaction products are carbon monoxide, carbon dioxide, SO2, hydrogen, and nitrogen. These gases are transported by the carrier gas to the detector, and then you get an element concentration. In case of carbon-sulfur analysis, please be aware that this kind of analysis is always a destruction of the sample, which does mean you are starting with a maybe powdered sample, and after the combustion you have just a residue which can be no longer used for other analysis steps. One possible analyzer for carbon-sulfur analysis of powder could be Elementrix CSI. It utilizes an induction furnace and measures the released gases with infrared cells for CO2 and SO2. This kind of analysis is like maybe also available at other manufacturers, but these kind of analyzers are usually compliant to the ASTM E1019 or to ISO standards like 7524. To get aware of the difficulties for correct powder analysis, I would just like here illustrate the single steps of analysis with the carbon-sulfur analyzer. When you log in the sample in the software, you usually don't have to care about the chemical composition or something else. This step is not critical. The next step could be critical because depending on the chemical composition of your sample and I would say the fineness of your sample, you maybe have to adjust the sample which is suitable for the correct analysis. It's also important to use the correct accelerator. For example, iron-based samples can just be processed with tungsten as accelerator, but some carbides or, for example, cast iron samples, they could require different accelerators. About this fact, we'll talk in the following. Placing the crucible with accelerator on the pedestal is not critical. It's also not critical to press start in the software. But again, we also have to consider the sample shape when we are going to the burning process of the sample, because the more fine divided a powder is, maybe you more get trouble with a not complete combustion. And there I can provide you some general typical sample weights and accelerator which are suitable to avoid swirling of the sample. Detection of the gases and calculation of results is more or less not depending on the sample shape, and here we would not expect any technical issues. So before you start analyzing a powdered sample according my recommendations, please be aware of difficulties which could come up when you're analyzing a sample which you maybe don't know. First of all, it's very important to know, is my analysis safe? And this is something which we are facing here in our days a little bit more because samples, for example, which are used in battery productions, they contain very hazardous products like cobalt or lead, and maybe also critical substances like lithium sulfate, which are toxic and hazardous. It's also possible that, for example, your sample could release the fluorine acid. So that just means, for example, you can get corrosion inside this analyzer, and the release of fluorine acid may be hazardous for your environment. The other thing is that some samples, for example, which maybe contain acids or a high halogen content, they could release elemental halogens and also maybe acids like chlorine acid, which could damage the analyzer and could also be harmful for you. Besides the safety information, please be also aware that, for example, you have to consider the heterogeneity of the sample. Here I show you a picture of a very hazardous and heterogeneous lead slag, because this kind of sample, for example, is very critical for this analyzer. You have to be aware of the safety when you prepare the sample, but this sample, for example, is heterogeneous. It can absorb water. And for example, when you store it in long time at air, it also can absorb CO2. This, for example, is an effect you also have to consider when you have a fine divided powder, because storing could also falsify the results. Nevertheless, when you now think, okay, I can analyze my sample safety, and I also make sure that I would say the heterogeneity is I would say is acceptable, and I also have make sure that no hydroscopic effect takes place. Then you have to think of what is a suitable sample weight, what is a correct accelerator, and how can I avoid swirling of the sample because it's so divided, fine divided, and which things do I have to consider when when I would like to avoid absorption effects? For example, moisture and copper dust can falsify especially the sulfur results. When you have to analyze a completely unknown sample, please perform a risk analysis before you do any combustion or any analysis, because some samples, especially slags, for example, or maybe samples from the battery production, they could contain a lot of substances which are hazardous, because cobalt, for example, or lead. When you combust this sample in a elementary CSI or in other suitable analyzers, please be aware that you are producing very fine divided powder. And this fine divided powder of, I would say, hazardous substances could mean that you have a big risk when you're doing a maintenance for this kind of analyzer. So please be aware of this risk and evaluate if you have to do something for safety for your stuff and for the analyzer. One common thing which can be solved easily is, for example, the release of pure halogens when you're analyzing salt-based sample or acidified samples. When you have an analyzer like the Elementrix CSI and you have to make sure that, for example, halogens are absorbed, which can, for example, damage the analyzer, then you have to apply a halogen trap. And then with this kind of trap, you are sure that no halogens are getting into the detection part of the analyzer and destroy the analyzer. When you are starting with analyzing a powder, you maybe get very irritating results. Here on the left side, for example, you see typical results of a lead slag, which is a slag which is, I would say, a waste product of battery production. And here you see that we have a very strong deviation in the carbon results, which, for example, starts with 0.5% and goes even up to 16.5%. And it's more or less the same for sulfur, which starts with approximately 7%, but can get up to 12 or 13%. And this is something which could also happen with your sample when you don't know the exact chemical composition and you are facing that maybe this kind of slag or heterogeneous sample can cause such fine deviations. When you only would like to get a rough idea about the chemical composition, then everything is fine and you don't have to do anything more. But maybe a more, I would say, correct analysis is required as, for example, for comparison results which are listed on the right side. There we analyzed furnace dust, which is also fine divided powder with comparable sample weights, but here we have very stable results even in the low concentration range. So when you are faced with heterogeneous samples, think about, should I spend more energy on the sample and prepare a more homogeneous samples, for example with ball mills, or can I accept the results we are facing here? When you are going to a more sample preparation and, for example, divide the powder in more finer parts, please consider that sample preparation on the one hand could falsify the results and maybe is also toxic or hazardous for the users which take care of the sample, because lead samples or other toxic samples can of course also release hazardous substances when they are prepared in a ball mill. Irritating results can not only be caused by a heterogeneity of the sample, but also by chemical effects which take place especially in powdered samples. Powdered samples can, for example, absorb CO2 due to their high surface, and maybe they are porous inside. And one strange thing which can also happen to a powdered sample is that you have absorption of water. When you have a minor determination of carbon and sulfur, then maybe you only have, I would say, something like a moisture effect, that you have minor determination because the sample absorbs water. When you have good luck, then this effect is reversible and you can just dry the sample and then measure it again, and then you would get correct results. But some samples, for example, which are especially used in, I would say, spectroscopic samples like salts, or maybe samples which are used in battery production, you also are facing the different effect, because you don't not only have the absorption of moisture, but you also have a hydrolysis of samples, which does mean, for example, lithium-based samples could really react with the water content which is in the atmosphere and falsify the results. When you have I would say, the job to measure samples which really have a strong hygroscopic effect, then you don't can perform this kind of analysis in, I would say, in a conventional carbon sulfur analyzer. Then you have to use, I would say, a glove box unit with separate combustion unit and detection unit. Then you can place a combustion unit in a, I would say, glove box, which can be prepared with, I would say, oxygen-free maybe atmosphere, and also atmosphere which is free of water. And then it's possible to apply a clean and dry sample. When you have samples like this and would like to get more information about this, I would say very rare application, then you can contact us again and I can provide you some additional information. When you now would like to start with carbon sulfur analysis of your powdered sample, you have to ask yourself different questions. What is the working range of my analyzer? Because when, for example, you have a carbon-rich sample, you have to consider the approximate carbon concentration, and then you have to adjust the sample weight. You have to also think about the, I would say, heterogeneity of the sample, because when you have a very homogeneous sample, it's maybe allowed to apply very low sample weights between 50 or 100 milligram. When it's a little bit more heterogeneous, then maybe it's suitable to increase the sample weight up to 100, 250 milligrams. More is maybe not allowed, because otherwise you will have a swelling of the sample. The application of the sample weight could be reduced due to the chemical base of the sample. When you have a sample, for example, which is based on a titanium powder, I would not recommend to apply more sample weight than 250 milligram, because the the titanium in the sample can no longer be oxidized when it's present in a too large volume. Then, when you have to think about the correct sample weight, then you have to think about the accelerator. Typically, for powder-based samples, you can just apply 1.7 gram of tungsten, which is usually 1 spoon, for an iron-based sample. This is quite a typical application, and then you are on the safe side for analysis. When the sample is, for example, ceramic based, then you can apply 1.7 gram of tungsten and 0.7 gram of iron. This is also a typical application for not iron-based samples to get reliable results. One other chance to run your sample is the application of ELTRA, which does mean you can apply the combination of tungsten and tin as accelerator, which provides the highest energy. And there you can apply typically 2 grams. When you get irritating results with these accelerator and weight combinations, please make sure that you don't have something like unwanted effects. For example, maybe swirling of the sample, which does mean that a sample is blown out of the furnace, or that your sample, for example, has a large copper content, which produces so much copper oxide, which absorbs CO2, or maybe your sample contains water, which does mean that the released water content absorbs the SO2 and causes minor determination. We will talk about these unwanted effects in detail a little bit later. When you are faced with the analysis of unknown samples, you will here find a short list of typical samples and the recommended applicable sample weight and the recommended accelerator. For ore, slags, and building materials, typically sample weights between 100 and 150 and maybe up to 250 milligrams are recommended. For fine dusts, which are maybe blast furnace dust, for example, you can also use the same accelerator, but you have to reduce the sample weight down to 40 up to 70 milligrams. It's the same for salts or for carbides. As mentioned before, you don't have to write down this list because you can uh, I will just publish these slides for download, so then it's easy for you to put these slides for your information to your desk. On the right side of this table, you'll find the information software settings, dusty and solid sample. And this is especially created for the settings of the Elementrix CSI because this analyzer can provide you different combustion steps to make sure that your sample is on the one hand combusted completely, but on the other hand, sample is not blown out of the crucible. The effect of the oxygen supply for a correct analysis is illustrated here. The Elementrix CSI offers the chance to, I would say, supply the oxygen by two ways. On the one hand, you have the lens. On the other hand, you have the chamber oxygen supply. When you're only working with the lens oxygen supply, you can make sure on the one hand that the sample is very well combusted, but the more fine divided your powder is, the more you could get trouble with swirling of the sample, which does mean the fine divided powder is swirled out of the crucible because the high steam of oxygen just is put on the crucible and fine divided powder is blown away. And when you apply a dusty application in the Elementrix CSI, you first apply a stream of oxygen, which is supplied by the chamber, so that you, I would say, start the combustion process. And in the middle and at the end of the combustion process, you just apply the whole oxygen via the lens. So you make sure that everything of the sample is combusted. And here we will find the suitable application settings for the Elementrix CSI, which are located in the application settings. And which does mean when you have in mind the table we discussed before, when you apply the settings of dusty sample, we have an automated setting for the lens and for the chamber so that the sample is first combusted with the stream of oxygen applied through the chamber, followed by the application of oxygen by the lens. So this is a good, I would say, interaction between these oxygen streams that no, I would say, powdered sample is blown out of the furnace. When you are very familiar with these kind of application settings, you can also go to advanced, and which does mean you can definitely find on your own which time of, I would say, chamber oxygen supply and lens oxygen supply is suitable for you. When you have more, I would say, analytical questions how to use this setting, or when you need a little bit more information, you can on the one hand go to the application notes of ELTRA, or you can just write us an example or a question to the email address webinar@eltra.com, and then we can discuss special sample settings for your sample. The correct application settings in the software. the utilization of the correct accelerator, and the utilization of, I would say, a fitting sample weight usually causes a good repeatability in results. And here we have, I would say, some typical results which are processed usually as powder, which does mean, for example, the analysis of ferromanganese with a high carbon content of approximately 6 or 7%, and, for example, dust samples which are applied with a sample weight of 50 milligrams and even a higher carbon content of 37%. So when you are using iron and tungsten as accelerator, set the application settings to a dusty sample, you can get repeatable results like this. So this does mean in general, when you have a not hazardous sample and have a homogeneous prepared sample, powder analysis in general is no problem and no challenge for you, but you have to consider all these facts regarding application settings and sample weight and accelerator. For me, it's important to provide some more information about other typical helping tools for correct analysis of fine divided powders, which does mean you can apply a lid on the sample. For example, these kind of lids, which can also be purchased by ELTRA, is a good helping tool when you would like to measure carbon content in a very, I would say, narrow range. But depending on your sample composition, it could be that this kind of tool could falsify the results of sulfur. This is just to the fact that, for example, the lens, which is putting the oxygen stream directly on the sample, is maybe blocked a little bit. And this does mean that the resulting temperature in your sample could be a little bit reduced. So in general, I could make a recommendation that lids on the crucible are only recommended for correct carbon analysis, but the sulfur analysis could be correct, but depending on the boundings in your sample, it could be that the measurement of sulfur is affected in a negative way and can cause a minor determination. So please, when you have a really complete unknown sample, check it with the application of lids and check it without the application of lids to make sure that you get correct results. When you need more, I would say, representative analysis data and correct setting for your analyzer, then you can also ask for an application note we already have published for a lot of samples. For example, we have been analyzing ore powdered samples, limestones, soil, glass, and also sulfides, ferroalloys, and lead samples, for example. So when you now see an application note which is interesting for you, just write me an email or write me a note, and then I can send it to you directly. At the end of the topic of carbon sulfur analysis, I would like to summarize it like this. For example, when you are observing trouble in analyzing your sample, you usually have different use cases. For example, on the one hand, you could have stable measurements, but the result is too high or too low. In such cases, I would recommend check if the calibration is in a suitable range. You see the example before, for example, that the dust provides a carbon content of 37%. Usually, an analyzer is not calibrated in this high range, but when you get stable results, but the expected carbon content is wrong, please make sure that you calibrate it in a correct range. You can use also other CIMs than the SLAC for calibration, but you have to make sure that you are using the correct accelerator. So, which does mean for very high carbon contents, for example, you can also use graphite for calibrating, but you have to use the same accelerator as for your sample, which does here mean you have to apply iron accelerator and tungsten accelerator. In general, a too low concentration could also mean that the sample already has absorbed some moisture. When you perform a measurement but you don't get any results, then please check the measuring curves because it could mean that you have a saturation of the channels, especially for samples which have very high concentrations of carbon and sulfur. It could be possible that the ER cells are saturated and do not provide a suitable result. In such cases, only a reducing of sample weight is recommended. When you only have a minor determination of sulfur, Please consider, I would say, the unwanted effects I mentioned before. It could mean that you have an absorption due to moisture. And this does mean please replace the anhydrone tube below the dust trap because then it is worn, you have moisture inside, which again absorbs the SO2. Also check the temperature of the dust trap because it could mean when the dust trap is no longer working reliable, you also have a condensation of water here, which again absorbs SO2. When the sample absorbs copper, it could mean that you have to again have to contact ELTRA because we have to provide a very smooth combustion. When you release by an intensive combustion copper oxide, this copper oxide also absorbs SO2, and this could cause a minor determination. The last error of, I would say, minor determination of sulfur, which is also typically for this kind of analyzers, is a worn Balston filter. When it's worn and contains some moisture, you also have the effect of absorption SO2. The biggest challenge for user usually is the measurement of deviating carbon and sulfur results. When you are getting deviating carbon sulfur results for your powder, which more or less is for you an unknown sample, please go back to CRMs and check if the analyzer is working properly with CRMs. When it's working properly with CRMs, you have usually the big chance that the deviating results is just only caused by the sample. When you think that it's caused by the sample, you should play with the sample weight, which does mean on the one hand reduce it because maybe on the one hand your channels are saturated, or you can increase the sample weight to provide a more homogeneous sample. It could also mean that deviating results are caused by, I would say, very varying sample weights. When you have, for example, a fine divided dust, you cannot apply in the first measurement 50 milligrams, in the second measurement, for example, 150 milligrams. That could cause a big irritation in the analyzer. So when possible, provide very homogeneous sample weights like, for example, 50 milligram plus minus 10 milligram. Also make sure when you're getting irritating results that the correct accelerator is applied. When you have samples, for example, like ferrotitanium, you always have to apply iron accelerator in addition. Otherwise, you would get not stable result because the sample is not combusted completely. When you have very low concentrations of carbon and sulfur, make sure that you are using a premium accelerator because there the deviation of carbon and sulfur is very, very low. When you only have, I would say, deviating carbon results, and these carbon results are, I would say, measured in a very low concentration range, really below 0.1%, make sure that the crucibles you are using are calcinated, which does mean they are preheated at 1000 degrees in minimum for 1 hour. This would reduce the blank value of the crucible. When you, up till now, have not analyzed powdered samples in your analyzer, of course it's possible to contact your local ELTRA partner and send him a sample free of charge for a test analysis. When you're already customer of ELTRA and, for example, you're facing some trouble with your sample, it's also possible to send us this sample so that we can make a test measurement. You will find all addresses and contact persons in the internet at www.eltra.com. When we are now talking about correct oxygen, nitrogen, and hydrogen analysis, on the one hand, the problems are the same, but on the other, we have other difficulties because the chemical composition and applied sample weight is something different for an ONH analyzer in comparison to an CS analyzer. Please consider when you are using on the one hand a carbon sulfur analyzer and on the other hand an ONH analyzer that the problems for unknown powder analysis could be a little bit different because this is just two several facts because for ONH analyzers powdered samples usually has to be applied as in a capsule, which does mean a reduced sample weight but also could mean an additional risk for blank values. The other trouble is when you don't know the exact chemical composition of your powder, it's maybe critical to find the correct, I would say, application power. In a carbon sulfur analyzer, we always have the constant power, just given by the kind of accelerator. In an elementary 1HP2 or other 1H analyzers, the applied power has to be adjusted for every analysis a little bit different. Depending on the chemical composition, you also have to consider that you maybe need some flux. And it could also happen, and this is something which has to be clarified before user starting analysis, it could happen that some samples, for example, stick on the other electrode. For example, lithium-based samples could show some very bad effects. For 1H analysis, ELTRA is utilizing the Elementric 1HP2. It's an inert gas fusion analyzer with electrode furnace, and it measures the elemental oxygen, nitrogen, and hydrogen. Hydrogen and nitrogen are measured in a thermal conductivity cell, whereas oxygen is measured as CO2 in infrared cells. This kind of analyzer is compliant to more or less every international standard, which we discussed before, for example, ASTM E1019. In this slide, I just compared the two different techniques which are used for CS or ONH analysis, so that it's easier for you to evaluate the differences when you have unknown powders, of which effect you should take care. CSI always means combustion in oxygen atmosphere, which just means you are releasing CO2 for the embedded carbon content and SO2 for the embedded sulfur content. The things you can vary is typically the kind of accelerator, which just means tungsten or tungsten tin or tungsten and iron. For an elementary or an HP2, it's a little bit different. You are using inert gas fusion for this kind of sample, and oxygen is measured as CO2, whereas hydrogen and nitrogen are measured in elemental form. Here you don't vary an accelerator, but some samples, for example, like titanium, they need flux material like nickel baskets or nickel capsules, and sometimes high oxygen samples need additional graphite. So here you have to take care of other accelerators and other fluxes. The correct analysis of powder for ONH could be critical at different stages of the analysis process. In contrast to CSI, already the lock-in of the sample could be a critical thing because the method which is used for lock-in determines the kind of power you apply to the sample, which does mean when you have, for example, a refractory-based sample, whereas you usually analyze steel, you cannot use a steel method because the applied power is too low. Weighing of the sample is also a critical thing because some titanium-based sample, for example, can only be applied with a reduced sample weight of approximately 100 milligram. When you apply to the sample to the sample port, you also have to think different when you analyze powders in contrast to analyzing solid samples, because for powders usually always a capsule is required. Placing the crucible, the crucible on the electrode and starting analysis is more or less not affected by the kind of powder. So I would say the rest of the analysis process is not affected by the shape of the sample. Before you start with oxygen, nitrogen, and hydrogen analysis, please go through the steps you also have done for the CS analysis, which does mean first think about the safety of analysis, which does mean when you have powders with harmful components, you maybe have to make sure that for maintenance, the user is not affected by the fine divided dust. Please make sure that the release of halogens, which are maybe present in salts, are absorbed by a halogen trap, which can be also installed in the elementary ONHP2. The deviation of results, again, can also be caused by the same effects which are relevant for CS analysis, which does mean heterogeneity of the powder, oxidation of surface, or maybe hygroscopic effects. like in the Elementrix CSI, and here the effect is even bigger. You also have to consider about a suitable sample weight. You have to use here a correct flux for materials, and you have to use a correct analysis power. What does this mean in detail is discussed in the following. Typical hazardous products for ONH analysis encompass lead-based samples, lithium-based samples, or cobalt-based samples, which sometimes came from the battery production. And especially when you are doing maintenance, you have to make sure that the dust, which is maybe condensing in the inside of the furnace or on the upper electrode, is not breathed by the user, because this could mean a high risk for the user, especially in ONH analyzers. The dust, which is released from the sample, is very fine divided and could be a risk for every people who are performing maintenance here. The release of halogens from the sample, for example, by the analysis of salts, must also be suppressed. And this can be done by, I would say, a small halogen trap, which has to be purchased separately, because the halogen absorbing material can be used in an already present chemical tube. When you would like to analyze halogen-containing samples with the Elementrix on HP2, you just have to make sure that you are using a halogen trap, which is located here in the dust trap of the furnace. You just have not only to fill it with glass wool, you also have to apply the halogen trap, which is usually based on antimony and potassium iodide. Please be aware that this absorption of halogen only is suppressing the release of halogens inside the detection unit. When you are analyzing halogen-containing samples on a regular base, you maybe would see effect on the inside of the furnace, because uh, halogens will be released from the sample, maybe directly into the furnace. And there, in these cases, I would say a good maintenance cycle is recommended anyway. When you have the challenge to analyze oxygen in a metal-based powder, please make sure that an effect like a surface oxidation may take place. I have here two examples to illustrate how big this problem, for example, could be. We organized around Robin toast of a titanium-based sample. You see here on the a yellow or maybe orange table that different labs, for example, supplied different results, which range from an oxygen content between from 77 ppm up to 1250 ppm, which does mean we have a range of more or less 500 ppm in the oxygen content. And this could be caused by, I would say, different status of the surface, which does mean when you measure a sample today and send it to other customers or to other labs, please make sure, or you please be aware that in this time the surface maybe could be oxidized. This was measured for titanium-based samples. For example, we also made some other examinations with iron-nickel feedstock samples here. We get this sample in, let's say, not argon-flushed glass, analyzed it immediately, and after 2 weeks again. And here we are not facing a problem with surface oxidation, just due to the fact that maybe we have a constant, I would say, oxidation of the furnace, which of the sample, which does mean when once oxidized, maybe no further oxidizing take place. This is something which cannot be predicted for, I would say, every metal powder, but please be aware that these effects could take place and that you can get irritating results, although everybody has measured the samples correctly. As for CS analysis, you can have some very strange absorption effects, which does mean a high fine divided powder, for example, could absorb CO2, which again could show higher oxygen contents. The other thing is the absorption of water. On the one hand, you just maybe have a small minor determination just to, I would say, a wrong taken sample weight, but especially for battery samples, it could happen that you have a strong hydrolysis of the sample, so which does mean you have a complete changing of the chemical composition of the sample. When you are in charge of analyzing samples which are such hygroscopic, please contact ELTRA again. Like for the elementary CSI, we can offer you special configurations for, I would say, oxygen-free and hydrolysis-free application because we can place the combustion unit in the glove box. This slide should illustrate all the details which could be important when you have to analyze the powder for your first time. First, have a look at the sample shape, because pure powders always have to be applied in a capsule. But when you have, I would say, granule or shipped samples, which are maybe unknown for you because at the moment you are only analyzing solid samples, please be aware that I would say granule samples maybe can be applied directly to the furnace, and this could have some advantages. I will show you an example in the following. Then please have a look at the chemical composition of the sample or the approximate chemical composition of the sample because this will influences a lot of single steps. On the one hand, maybe the sample weight is reduced when you have, for example, titanium-based or refractory-based samples, and then you cannot apply more sample weight than 100 milligram. When you have, for example, samples which are new for you, and then you have to also consider, for example, a different chemical composition, maybe you have to take care of nickel baskets to make sure that the analysis is correctly. One other thing is the applied power. When you're, for example, familiar with copper analysis and are familiar with the applied powers to the analyzer, then you have to think something new when you are now analyzing steels or slags, because then the power has to be much higher to make sure that the analysis works correctly. Again, you have to divide your application in an ON application and an hydrogen application because on the one hand, the flux could be a little bit different and again, the applied power could be a little bit different. So these three questions, sample shape, chemical composition, and element to be measured has to be answered before you start a new analysis. This slide should illustrate different sample shapes which could be applied to the elemental ONHP2 furnace. Drilled and chipped samples, which are shown in the pictures above, can be applied usually directly to the furnace, maybe with a sample weight up to 1000 or even more milligrams. You have to consider some typical application settings, but this is something I will show you in the following. When you have powdered samples, for example, metal powder or maybe ceramic-based powder, you always have to apply this powder to a nickel capsule because it's not possible to apply powder directly, otherwise it would just stick inside the furnace and would not fall into the crucible. When granule samples are analyzed, you have to go to your application, which is defined in the application window of the Element software, and then you have to switch off the setting purging while closing. Because when you switch off the setting, no additional gas stream is applied to the furnace, so that that all of the sample stays inside the furnace and is not blown out. When you would like to test the sample amount which is applicable to the furnace, I would recommend the following test procedure for your sample. This test procedure, for example, could be suitable when you run granule samples for the first time, or when maybe the sample preparation now has done in a different sample shape, and you are now completely unsure if, I would say, all the applied sample will fall into the crucible and which sample weight is suitable for this application. So the following procedure could be suitable. So when you have an unknown sample in a granule shape, first weigh the sample on the balance and apply it to the furnace. Then you go to the balance again and weigh a new graphite crucible. Tell this weight and apply the crucible to the sample port and close the furnace. And then it's possible to go to the furnace manual and click on Clean Furnace. This does mean that the slider opens and all the granule samples which is applied to the furnace will now fall down into the crucible. and then you weigh back the sample on the balance. And when the applied weight of the furnace and the measured weight on the balance is the same, you can be on the safe side that all of the granule samples will fall directly into the crucible. This thing could be sometimes a little bit tricky when you have drilled samples or I would say an unusual sample shape, because then you maybe have blocking in the furnace. When you have blocking in the furnace after this test, it's more easy to clean this furnace just with a brush because you have not performed an analysis which maybe causes sticking on the upper electrode. For your information, I just put, I would say, typical metal samples which are analyzed with the Elementric ONHP2 on this slide. Here you will find the typical sample, the elements which are usually analyzed for the sample, and which is a typical sample shape and applicable sample weight if you need some fluxes, and where you can find more information in relevant standards. And on the last column, you find information about for which type of analysis you can use these general settings. You don't have to write this table down because you can download it at the end of this webinar as a PDF document. In addition, you will find here a temperature curve of the Elementric ONHP2. So for example, there you get a feeling about, I would say, applied voltage or power to the analyzer and the resulting temperature. For example, which does mean when you apply a temperature of a required power of approximately 1800 watt, you usually get temperatures about 1000 to 1100 degrees Celsius, and copper will melt. This applied power for melting is I would say, rough estimation of which kind of power you need in minimum. But please be aware that you have to not only melt the sample, but also you have to crack the bondings which are inside, which does mean copper, for example, will melt at 2000 watt, but the bonding of copper oxide inside the sample will only be cracked when you apply a higher power of, I would say, 3500 or 4000 watt in minimum. So this should be a rough orientation when you have an unknown sample, maybe an unknown slag, and you know that, for example, silicon oxide is inside, maybe titanium is oxide. Then you also have to apply a very high power to make sure that the sample is melting on the one hand, but on the other hand, that the boundings which are inside the analyzers are inside the substance are cracked. And here we have a summary of, I would say, used crucibles and used flux materials and applied power for typical based samples, which just mean iron-based samples, copper-based sample, or titanium-based sample. And when you have a look at this table, I also would like to give you the hint that it maybe makes sense to increase the applied power for your sample when it's now in powder shaped. I had, for example, a customer who processes copper samples at, I would say, typically 3500 watt, and it get good and repeatable results. Then he get once powder-shaped samples, and nothing happened, and he does not get a repeatable results. This is just due to the fact that this powder sample has a very high oxygen concentration, and the analyzer was not able to process this high sample weight with this applied power. So this does not fit together. And this is something you also have to be aware of when you, for example, only analyze a steel sample, which is, I would say, present as a solid sample or as a pin. Then maybe the applied power is high enough to get a good result for this kind of solid sample. Powder could mean that you have to increase the sample power, and it could also mean that you maybe have to increase the sample power for analyzing this sample about 10 or 20%. Otherwise, you maybe are not sure if you can crack all the boundings which are inside. So please take this as a general recommendation for analyzing unknown samples, but always be aware when you have powdered samples that the applied power could be much higher. Here, I just would like to give you, I would say, typical example of analyzed powders with the elemental ONHP2. Here we had a sample of iron nickel powder, which was a feedstock of a customer. We applied for oxygen and nitrogen analysis a sample weight between 150 and 200 milligrams and get repeatable results for oxygen and nitrogen. It was the same for hydrogen. There we applied even higher sample weights of approximately 400 milligrams, and here we also get repeatable results for hydrogen. In such cases, the only difference between, I would say, a standard analysis of steel and of solid sample and analyzing steel or iron nickel in a powdered sample is that you have to apply the sample to a capsule, and the applicable sample amount is limited just to the volume of the capsule. And here, for your information, it's also possible to run more or less exotic powders with the elementary on HP2. Here we had a manufacturer of precious metals, and they sent us some palladium samples. And like the steel sample, you can just fill in the sample in a capsule and analyze it. And for this kind of precious metal, it was necessary to not only apply the sample to a capsule, but for oxygen analysis, we have to use a high sample amount, power of approximately 5,600 watt. So then the analysis of precious metals is safe in the analyzer. When you're going for hydrogen analysis, you can apply a lower sample weight or a lower sample power, and then you can also get repeatable results for hydrogen. And this is sometimes the challenge you are maybe facing when you are getting unknown samples the first time. You maybe feel not familiar with this, but so I can give you some recommendations for general application of powder. Of course, we already prepared some application notes for powdered sample. For example, where we published some application notes for nickel powder or steel granulates and drillings, and we also analyzed different ferroalloys and silicon nitride. When you would like to get some of these application notes, just send me an email or write it here in the questions, and I can send it to you directly. When you have other substances which are not familiar with these kind of materials, you can also write me something in the chat, or can just write me an email later on, and I can give you some recommendations for the correct analysis of this kind of sample. When you are facing some trouble with analyzing these powders, usually it's good to follow these rules which are mentioned below, which does mean when you get stable results, but the results are too high or too low, like in the CSI, check first the calibration if your analyzer is, I would say, calibrated in general in this calibration range. You can use different reference materials, but please make sure that they always have the same flux if you have to need someone. When you have general two values, then please consider that maybe you have an absorption of moisture in the power, or that the applied power in general is too low. Or maybe you please consider that meanwhile the composition of the sample has changed, especially, for example, when you have hydrated sample and you store it in atmosphere, make sure that the hydrogen is not lost, which does especially to titanium hydroxide, for example. This titanium sample is oxidized in the time and will lose hydrogen over a large period of time. When you don't get any value for your measurement, it maybe indicates on the one hand that the sample is not melted at all, or it could indicate that the sample again saturates your sample because some slags could have a very large concentration of oxygen and nitrogen. When you have, in contrast to the expected value, a massive to high nitrogen or oxygen content, you maybe have to perform some maintenance. Nitrogen and hydrogen, which are measured extremely too high, are maybe caused by a saturation of the chemical filter which is sitting before the TC cell. When this chemical filter is saturated, you will also get immediately very high concentrations for nitrogen and hydrogen. When you only get this kind of very high concentrations only for oxygen, then it's recommended to check the upper electrode because some samples could be very aggressive to the nickel layer on the upper electrode, which does mean when this nickel layer is removed, the crucible will get in direct contact to the mass of the upper electrode, which does mean the copper which is inside the upper electrode is analyzed directly, and this could cause a very high oxygen content. The most demanding challenges in ONH analysis is always the get rid of deviating results. And when you are getting deviating results for your powder, it's the same as first step. The first step is always run a CRM for controlling the analyzer, which does mean when you are getting deviating results from your sample, please go back to the CRM and check if the analyzer is working properly. When the CRM is working properly and can be analyzed according to its definitions, then start with evaluating single steps, which could mean something different here. On the one hand, you can also reduce the sample weight because then, for example, you also avoid swirling here, and you can improve the combustion and fusion of the sample. When you increase the sample weight, it's also possible because then you can improve the repeatability when you have heterogeneous samples. Some samples are very sensitive, especially in the elementary ONHP2 regarding the applied weight. So please make sure that you always apply a constant weight to the furnace. One other thing is bubbling, which just means a sample could form bubbles, which does mean the sample migrates to the upper electrode. Bubbled samples cannot be used for evaluation of the measured results because then you get wrong results. Please make sure that you apply the correct flux material because it's not possible to analyze titanium samples for oxygen and nitrogen without application of a nickel basket. So this is something which has to be considered when you have an unknown powdered sample. So at the end, I would just like to give you a short summary because maybe you recognize that some hints for carbon sulfur analysis and oxygen, nitrogen, hydrogen analysis are the same for powders. And most important is when you are getting a new powdered sample and you're not familiar with analyzing these canned samples, please make sure that the analysis is safe, especially, for example, samples which contain lead, cobalt, and other toxic ingredients. When you have a powdered sample, the damage for the analyzer and especially for you as human being could be much more in comparison to a solid sample. The composition of the sample can easily be changed when you apply it to a sample preparation step or when you store it, because then you have oxidation effects. You maybe other elements can be introduced or they can be removed by this analysis steps. So this does mean when you are getting irritating results, always consider the whole analysis process. Due to the high concentrations in these slags, for example, or powdered sample, it could be that you are not that you cannot process your sample in, I would say, in a sample which is common for you, which does mean, for example, when you have very high concentrations of oxygen or nitrogen inside the sample, your channels would easily be saturated by, I would say, typical sample weights of 200, 500 milligrams, for example. Swirling of the sample is especially one problem for CS analysis because the more fine divided your powder is, the more the combustion of the sample in the crucible can affect the correctness on your results. You can solve this problem by application of lids, which maybe affects the sulfur measurement, or you can apply a special combustion procedure which allows you to process these samples safe. And for ONH analysis, most critical thing is the applied power. For example, when you are familiar in operating steel samples as solid samples, and now you are getting a steel powder, it could mean that you have to increase the applied power to make sure that all of the oxygen and nitrogen releases the sample. These are the most, let's say, important hints which I would like to give you when you are facing problems with analysis of powders. So, like before mentioned for the CS analysis, when you are not an ELTRA customer at the moment and you would like to get, I would say, free of charge test analysis, please have a look at the website and then you will find your contact addresses for a free of charge test analysis. When you are already an ELTRA customer and you are facing trouble with some samples, write me an email or write me a question in the chat and I can answer it. And of course, for you, it's also possible to send us a test sample where we can give you some recommendations for a correct analysis. So at the end, that's it. Thanks for your attention. I will stay online for a few more minutes to answer your questions or prepare documents for download. And again, when you would like to ask more questions, just send me an email at webinar@eltra.com. So I wish you a lot of success in analyzing powders and have a good time. Bye.